Today I will be talking about the Ullmann amination and the Buchwald-Hartwig amination. The two amination reactions are very similar, where both reactions start with an aryl having a halogen leaving group and an amine. They both have a final product of the aryl attached to the amine where the original halogen leaving group was. The major difference between the two reactions is that the Ullmann amination has a copper catalyst attached to the halogen leaving group that's on the aryl. The Buchwald-Hartwig amination has a palladium catalyst with a bidentate ligand attached. Both reactions have a mild base for the reaction to undergo. Here is an example of an Ullmann amination. You can see the aryl with the iodide leaving group and the amine. In this reaction, the amine undergoes a nucleophilic substitution with the copper, where the iodide leaves and the amine attached to the copper, followed by an oxidative addition of the aryl, so that both the aryl and iodide are attached to the copper. The final step would be a reductive elimination of the aryl and the amine, forming the final product, and the copper iodide catalyst is reformed. Here is a basic example of a Buchwald-Hartwig amination, where there's a different aryl attached to iodide and a different amine. In this mechanism, the first step is an oxidative addition of the aryl, so that both the aryl and iodide are attached to palladium, which is attached to the bidentate ligand, followed by a ligand association of the nitrogen. The amine is then deprotonated so that the amine and the aryl can undergo reductive elimination from the palladium, reforming the palladium catalyst.